Hello, good people, and welcome back to another math video. This is our 5-a-day math review, but this will have the answers for Tuesday, March 24th, 2020. Let's get started. All right, the first problem says there are 4 shirts for $32, and we're asked for the rate and the unit rate. Well, the rate is really pretty straightforward. It's usually we do the money on top, so $32, and that would get me 4 shirts. So that's just my rate, 32 for 4 shirts. And the second part is to asks us, what is the unit rate? Well, hopefully you remember this from class. When I say unit rate, you say divide. Unit rate, divide. Whenever we are figuring out a unit rate, we want a 1 in the denominator. So you can start out by looking at your rate, which was 32 over 4, and we want to have a 1 in the denominator. So how am I going to move from a 4 down to a 1? I need to divide by 4. So I have to do that to my numerator as well. And when I divide by 4 here, I would get 8. So my unit rate is 8 over 1, and remember that is dollars per shirt. So $8 per shirt. Number 2, it's a little bit hard to see on the PDF, but there are, it looks to me that there are 3 vertical columns shaded. That's why I wrote that. And each of those has 10 blocks. So we have kind of 10 in the first column, 10 in the second column, 10 in the third column, and all the way across there are 10 columns. So of course 10 times 10 is 100. So I have 100 total blocks, and I have 3 columns of 10 shaded. So that means I have 30 out of 100 shaded. For my decimal, 30 out of 100 would reduce to 3/10. My ratio, I could write this as 30 shaded to 100 total. And my percent would be 30%. So if you weren't sure kind of on some of these, let's talk about kind of how to make them happen. All right, first of all, the fraction, that's probably the easiest one. We're just looking right there, and we can see that there are 30 blocks out of a total of 100. So to move from a fraction to a decimal, well, if you know that it's 31/100ths, I can divide that 30 by 100, and that would give me 0.3/10. Also, I could drop these 2 zeros off, and because they're the same, the top and the bottom, and that is going to give me the fraction 3/10, and I just say that fraction 3/10, and that's the same as writing the decimal of 3/10. The ratio, 30 to 100, that's a little similar to kind of looking back here at the fraction. We have 30 that are shaded into out of a total of 100. Now for the percent, anytime we have a decimal, we can move to a percent by moving that decimal point kind of 2 places to the right and putting that percent sign in. So it starts out here, and after I move it 2 places to the right, I would have that number 30. So 30%. Number 3, what is 50% of 80? All right, proportion problem. Set up my 2 equal fractions, and I'm always going to have part over whole, percent over 100. So I got a 50% right in the problem. So I'm going to put that in, and I'll look at this. I'm halfway done. Now I have to just look at the question. Where does this 80 go? What is 50%? The question is asking you, what is the 50%? So they don't know. They don't know what the 50% is, so that means they don't know the part, because the part is lined up with the 50%. So that means my 80 is going to go on the bottom. Now I'm going to cross multiply, and on one side I'll have 100x, and on the other side I'll have 4,000. Divide by 100, divide by 100. These are going to cancel. leaving me just with x, and 4,000 divided by 100 is 40. So 50% of 80 is 40. Number 4, Ken grew 4/5 of an inch. Sang grew 3/8 of an inch. Who grew more, and how much more? Well, there's no way to do anything with these numbers right now because I'm trying to compare these fractions and they have unlike denominators, so it's very hard to compare them. So I'm going to come up with some like denominators. What you need to do is you need to have a least common multiple to do that. So I'll set up my GCF LCM ladder and I'll say to myself, what goes into 5 and 8? I really can't come up with anything. That's because the only thing that goes into them is 1. And 1 would go into 5 5 times, 1 would go into 8 8 times, and I know that if I draw my L here and multiply everything together, that is going to give me the LCM, which in this case is 40. So that's going to be my matching denominator. So 4/5 is going to become a certain number of 40ths, and 3/8 is going to become a certain number of 40ths. So how many times is 5 go to 40? That's going to go 8 times. I have to multiply by 8. So I have to do the same thing on the top. So that would give me 32. How many times would 8 go to 40? I'd have to multiply by 5. Have to do the same thing up on top, and that's going to be 15. Well, now they're a little easier to compare because now I can see 32/40ths and 15/40ths. I'm just actually going to put some initials next to these. This was Ken. This was Sang. Okay, so who grew more? Well, now I can see that Ken grew more. So I'm going to put that down. Ken grew more. Kind of that's like answer number 1. And answer number 2, let's see, they're asking how much. Well, anytime I have a how much more kind of problem, I'm looking at doing some subtraction. So I'm going to set up a big subtraction problem right here. And it is 32 minus 32/40ths minus 15/40ths. I can't do 2 minus 5. Got to borrow from the 3. Make that a 2. Make this a 12. 12 minus 5 is 7. 2 minus 1 is 1. 17, and I'm talking 40ths. So how much more did he grow? 17/40ths more. My next one, it says complete the table and then graph the coordinates. All right, so I can complete the table by following this equation. It says y equals x plus 2. Now at first it might seem a little crazy, but basically all this is saying is y is equal to whatever you have for x plus 2 more. So in the first one, what do I have for x? 0. So that's kind of like saying y is equal to 0 plus 2. Because remember, x is right here in the equation. And what is x equal to? X is equal to 0. So I just put that 0 over here. 0 plus 2. So in the first one, y is going to be equal to 2. All right, the next one, x is equal to 1. So that's kind of like saying y is equal to 1 plus 2. What's 1 plus 2? That's 3. And the next one, x is 2. So that's like saying y is equal to 2 plus 2. Well, 2 plus 2 is 4. In the next one, x is 3. So that's like saying y is equal to 3 plus 2, which is 5. And you might be seeing a pattern here. 2, 3, 4, 5. Every time it's just 2 more. So 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So 4 plus 2 is 6. And 5 plus 2 is 7. All right, I'm going to erase these real quick, get this out of my way. All right, I don't have beautiful graph paper on here like you do, but I can kind of do a rough job of showing you what this is going to look like. So I have my x-axis because x is my horizontal axis, y is my vertical one. So I'm going to look at these as kind of coordinate pairs. So my first coordinate pair is like 0, 2. My next would be 1, 3. My next would be 2, 4. Then 3, 5. 4, 6. 5, 7. So I'd have to graph these. So x is 1, 2, 3, 4, 5, 6, 7. That should be enough. 1, 2, 3, 4, 5, 6, 7. So for my first one, x is 0, y is 2. That would be right here. For my next one, x is 1, y is 3. That'll be right here. Now for my next one, x is 2 and y is 4. Will be here. And then x is 3 and y is 5. That would be about here. And then x is 4, y is 6, would be here. And then x is 5 and y is 7, that would be about here. Again, I'm sorry that I don't have graph paper, and I'm sorry that this doesn't look better, but you get kind of an idea of what that graph should look like. Okay. Well, that's it. Hope that helped. There's the end of our video, and we'll see you again soon.